Okay, so I was thinking kind of as a loose structure. If I went through a little bit about what the AZTEC protocol is, what it enables, and then Paul will speak a little bit about how to a bit the structure of our repo, because he's been doing a lot of DevOps work, making our repository a lot more user friendly, and also potential integrations with Zeppelin OS that we're exploring, because we're very excited with what you guys are doing and the tooling that you've created. So
awesome. Why don't you start introducing yourselves, please, in case there's some people joining or watching afterwards? It will be useful.
Okay, cool. So yeah, I'm Zach. I'm the CTO of AZTEC. I started working on this project with my co-founder Tom in roughly 2017, at the start of 2017. Back then, we were trying to create like a debt platform using Ethereum for the capital markets, and quickly realized that, well, we needed transaction privacy and we weren't going to get it from anybody else. And so around January of 2018, I started doing research into ZK snarks, Zero's proofs, that kind of technology, and discovered a potential solution to this problem of how to create private transactions on public blockchains in a way that's efficient enough for a platform like Ethereum, where the gas costs for computation are considerably are very high. So yeah, that's kind of that's been working on that ever since. That's my background.
Yeah, cool. And I'm Paul. I'm working as a software engineer at AZTEC. I joined the team like 1 month ago, and before that, I spent my time generally working on Ethereum, publishing articles, and I published this thing called the ERC-1620, which is a money streaming protocol, a way to distribute money, like, you know, once per block, per 5 blocks, and so forth. But yeah, now I'm working full time on AZTEC, and yeah, we're gonna start talking about it in a sec.
Great. Thanks. I'm Leo from the research team at Zeppelin, and here with us are a bunch of others from the Zeppelin team that will be asking questions, and you might see them appearing. This is our first experiment on YouTube on air, so be patient. We are playing with this, and we'll see how it goes. If it goes nicely, we will do it again. So thanks a lot for joining us, Paul and Zach. Sorry to interrupt you, and go.
Yeah, thank you very much. Yeah, it's great to be part of this experiment. So I guess the question is, well, at least the question I ask myself a lot is, how do you get private transactions on a public blockchain? How do you effectively have your cake and eat it? Because the overwhelming majority of the world's financial transactions today are done with the implicit expectation of privacy, where nobody can see what you're doing. And I think one of the key blockers for widespread adoption of blockchains is the fact that you can't, at the moment, it's extremely hard to get that kind of privacy while still enjoying the consensus of the blockchain's protocol. And so what we're doing at AZTEC is kind of, it's a way of squaring this circle by effectively enabling value transfer by encrypting what you're transferring, but using a branch of cryptography called zero-knowledge cryptography and zero-knowledge proofs to preserve enough information about what you're transferring that you can prove mathematical relationships. Really, really simple ones. Like, for example, if I want to send you, Leo, some zero-knowledge DAI, I need to send using the AZTEC protocol. I need to present an AZTEC node, a collection of value that's encrypted that I own, and I need to prove to the blockchain that I have to define a node that I'm going to give you, and I have to prove to the blockchain that the amount that I want to send to you, whatever it is, it's small enough that I'm not double spending, that I'm rich enough to do this, and that my leftover balance is what it should be. This is somewhat difficult to do, and there are several different kinds of technology that enable this. So there's just to give a kind of a brief overview of the space, there's ZK-SNARK technology, the stuff that Zcash is using. There's bulletproof combinational transactions that Mimblewimble will do, and ring signature kind of technology that Monero are using. And I've forgotten, there's some other ones, I'm sorry. Also ZK Starks, which is what Eli Ben-Sasson is currently working on. So for us, we have some rather specific problems to solve with the AZTEC protocol. A lot of the research that's been done in zero-knowledge technologies is for the purposes of general purpose computation. How can I create a program and prove that I know the inputs that satisfy this program without revealing what they are? However, for what we're doing at AZTEC, we need a much simpler kind of zero-knowledge proof. We're not trying to prove arbitrary computation. We're not trying to prove particularly complicated flows of logic. All we're trying to do is prove value transfers. And so what the AZTEC protocol does is it really creates, its zero-knowledge proofs are very bespoke and specific and tailored towards proving these kinds of balancing relations that were described earlier, these join split transactions, joining nodes, splitting nodes. And as a result, they're very efficient. And at the heart of it all is a kind of a range proof that we have, which is extremely efficient to verify and is baked into the fundamental way that you encrypt data on the protocol. Anyway, I know that's kind of getting into the weeds of it all. The implications of it and the consequence are, what we're trying to do at AZTEC is provide developers with the tooling and the resources and the infrastructure that they need to create private digital assets without having to be literate in zero-knowledge cryptography, without having to be a cryptographer, and to really understand the nitty-gritty of what's going on. Effectively abstract that all away by using our smart contracts, our interfaces, and our token standards. And so in November, we published our first mainnet implementation of the protocol as a proof of concept, which was yeah, it was fantastic to actually get that out there finally, because this has been something we've been working on for over a year. But that is just a small kind of taste of what we have planned for the AZTEC protocol. So I'm going to let Paul speak in a bit, but just to kind of summarize our plans. One of the, I think, something that has not really been tackled before in this space is confidential settlement, because there are several technologies that enable private value transfer, like Zcash, like Monero, like bulletproofs, like another ZK-SNARK technology, where you can do a unilateral transfer. I can send you some private money, but there isn't any kind of general purpose way of being able to do some settlement by this technology, to have two confidential assets and to trade them bilaterally with another counterparty. And that's kind of the essence of a financial transaction, and that's really what we're doing at AZTEC. We're creating a confidential token standard that will effectively have all of the same functionality that you would expect from the ERC20 token, except that everything, every action this token performs, it's kind of spoken in the language of zero-knowledge proofs. And what this will enable, at least what our plan is that developers and dApp builders will be able to construct relatively complicated confidential transaction semantics without having to be literate in zero-knowledge cryptography, by using our off-the-shelf proofs that we're kind of collecting in something that we're calling the AZTEC cryptography engine, which we are hopefully releasing an EIP for today. So yeah, there'll be some more news on that soon. So yeah, that's kind of a lightning overview of AZTEC. I'll let Paul speak.
One quick follow-up I would add on what Zach has said. Good mental model to think about this AZTEC nodes, at least like how I understood them relatively easily, is to think of them as like traditional Bitcoin UTXOs, in the sense that you have like an ERC20. With AZTEC, you can create input and output transactions with the catch that the sum of the inputs have to match the sum of the output. And that's basically the gist idea. And you can create a ton of different financial transactions on top of that primitive.
Yeah, he puts it better than I do.
Awesome. Yeah, like, it was a very nice explanation.
Oh, hello.
I think we lost Leo for a minute.
Yeah, we lost him for like, yeah.
I'm not sure, Paul, if we're planning on following up on a bit more technical explanation. I think you can go ahead if that's okay.
Yeah, sure. So I'll let Paul speak, because basically the way our last year was kind of our effectively the way is we had the training wheels on, and we were getting AZTEC to a point where we proved it works. We could formally prove it works, and getting a working implementation on mainnet. And the focus this year is really on implementation and turning it into a set of tooling that is ready for prime time. And
implementation needs to be scalable. So what we've been doing these days is to implement like a monorepo with Lerna, which is a very, very cool tool to use. And of course, we care about long-term upgradability in the sense that if we publish something, we do not want to ask developers or like other users, you have to change your contract address. So that's why we've been looking forward to use Zeppelin OS. We just try to like code like an alpha version, but it's not out there yet. But we're working on it, and like essentially we are planning this proofs package inside the big monorepo where everybody can just add proofs for whatever financial transaction they want. Currently, we're working on 2 of them. The first one is this bilateral swap, which essentially means just token exchange, but in zero knowledge on Ethereum. And the second one is a loan standard, essentially like a way to do syndicated loans across large institutions with a ton of money, but on Ethereum and with private confidential transactions. And yeah, that's on the rough roadmap for the near future, but everybody's just free to join. And if you have any ideas for cool zero knowledge implementations, just give us a shout out.
Yeah, so to follow up on that, effectively what we're doing with these zero knowledge proofs is we effectively see it as our job, our business, to construct these kind of zero knowledge protocols that other people can use for whatever purposes they want. And so effectively we're creating a grammar of zero knowledge proofs that builders can then use to combine in a modular fashion to create reasonably complex semantics. So for example, you can only enact a trade if you own less than 50% of a resource, or you have to have at least a certain amount of something to be able to trade it. Things like that, range proofs, or something else we're working to addition to develop our swap is interest rate payments, which and dividend payments, which I'm super excited about, because it's a way of basically proving in zero knowledge that you have the right to collect a certain interest rate payment. So imagine if there's some kind of digital asset that has provides 3% yield. How do you claim that 3% if your effect token holdings are encrypted in notes? You have to, you have a zero knowledge proof where you can say, okay, I've got this, like I want to create this new UXTO, and the computer is worth 3% of the note that I have. They're not going to tell you what's in either of them. And I think that's going to be, I think it's going to be pretty cool, pretty useful.
I think that uses homomorphic encryption.
Yeah. It's a lot of homomorphic encryption. It's been a hell of a lot of fun working on this for sure. Would this be a good time to pause to ask the folks online if they have any questions?
I think yes. Can you hear me?
Yeah.
All right. Something's weird happening here because I can see you, but I can hear you right, and I think everybody else is seeing you. So it seems we're good. I wanted to know a little more about homomorphic and these range checks that you're doing. I know I tell you it's going to be informal and not super deep, but can you tell us a little general idea of what this is about and like quickly, if possible?
Yes. So
how does it work?
Did you see the homomorphic encryption?
Yes.
Yeah. So at its very core, it's effectively a way of so specifically what we work with is homomorphic arithmetic, and homomorphic addition. The idea is using elliptic curve cryptography, you can if I encrypt two numbers, I can perform a kind of encrypted addition operation to get a third number out, which is a third encrypted object, which is exactly the same object as I would get if I took the plain text of those two original numbers, added them together, and then encrypted them. So, you know, the encryption of A plus the encryption of B equals the encryption of A plus B. It's really like as a concept, it's very simple. It's just rather hard to do in practice. And that is the kind of the crux of everything that the AZTEC protocol uses. To clarify that a bit more, it's a little bit different to ZK-SNARK technology, because the ZK-SNARK, well, it uses the same elliptic curves, the same primitives. In a ZK-SNARK, it's an arithmetic zero-knowledge proof. Basically, you use homomorphic encryption to construct a kind of a program that you can write in a kind of language, a bit like a pseudo language like C. And then you can prove zero knowledge that you know the inputs that will run this program correctly. Whereas in the AZTEC protocol, it's a little bit different, where the actual elliptic curve field elements, group elements, actually, they define an equation, and you have to prove that you can solve that this equation can be satisfied. So instead of, for example, in a ZK-SNARK, where the elliptic curves are used to constructing like extremely complicated high degree polynomials, what we do in the AZTEC protocol is our elliptic curve formulas or equations are extremely simple, relatively speaking, because there are how do I put this, like a direct expression of the mathematics we're trying to verify, instead of coding things up as a program. One of the consequences, actually, poor reminder, something we wanted to talk about, is the AZTEC protocol uses a trusted setup, like ZK-SNARKs, like Zcash, where it's certainly you generate toxic waste, and you've got to destroy the toxic waste, or bad things happen. And we have a multi-party computation protocol planned, whereby multiple people can take part. It can scale reasonably indefinitely. And the more people that are involved, the better, because every single participant generates a piece of toxic waste. And if only one of them acts honestly and destroys that toxic waste, the protocol is completely secure and backed by conventional discrete logarithm assumptions. And we're trying to involve as wide a range of participants as we can in this, members of the community, stakeholders, people using AZTEC. Is this something that Open Zeppelin would be interested in doing, participating in this ceremony?
Sounds super cool. I don't know. What do you think, Tim? I see Paula giving the thumbs up.
Fantastic. Because yeah, the way we do AZTEC really is kind of as infrastructure level stuff, as a kind of a resource, a public resource, a public good, and we want its security to be backed by as many stakeholders in the Ethereum ecosystem as we can enable. So that's fantastic. Thank you. Yeah. So sorry, that was a bit of a meandering answer to your question about homomorphic encryption. Did that?
Yeah. Well, I will have to read a lot more, but it was a very good introduction, and it sounds super interesting to continue reading with what you're building.
Well, one quick note I would add there is that in normal ZK-SNARK technology, you have this thing called the ranking constraint system, R1 CS. That's not something which is available in AZTEC, because, as Zach mentioned, we have simpler mathematical expressions, and that's why where the efficiency comes from. If you're trying to use the normal Ethereum precompiled contracts at addresses 5 to 8, you're gonna incur costs like over 2 million gas. With AZTEC at the moment is 900,000, and that's going to go down when EAP 1108 will be published. And we're also working on some very cool tools which will get that gas cost by a factor of 30% down. But yeah, it's very much efficient. That's the core idea.
Yeah.
So I'm sorry, I'm taking all the questions, but I have a few. then I will let the others interrupt. They are too quiet too. So I was looking at your code, and there's a lot of assembly, not much Solidity. Is that because of efficiency, or is that because Solidity doesn't support the kind of things that you need to do low level?
So it's Solidity supports the majority of what we want to do. It doesn't have, I don't believe it has any kind of native way to call these precompiled smart contracts to use, but that's a relatively small part of the algorithm. I mean, the small part of the volume of the code. The reason why it's programmed in assembly in Mule is because it is pure efficiency reasons. In AZTEC Zero's proof, the input data can range to up to like 2 kilobytes in size. And in Solidity, because the way it manages memories, it doesn't reuse memory. And so when you're dealing with these extremely large objects that you're chucking around and sending to precompiled smart contracts, and it incurs quite a significant extra overhead for having to copy all this memory over and over again. And so yeah, we are extremely sensitive to gas costs, and so that algorithm is written in yields as optimization.
Yeah, well, it gets complicated, but I saw a lot of comments, so I'm also eager to get a lot more into the code. And can you tell us about this EAP? Why will it save that much gas? What are you proposing in there?
Well, it's not our EAP. I believe who created it? Oh, I can't remember their names. Sorry. So I'm looking at it now. Just it is. Did make it.
It's 1108.
Yeah, contributors. Basically, it's making around the world. Basically, the precompiled smart contracts. Their gas cost is a reflection of the computational kind of burden on the network, and because the code cryptography is really expensive, these precompilers, the gas schedule was set at a relatively high rates, so it costs 40,000 gas to multiply an elliptic curve point by a scalar. However, since that change went live, since the Metropolis hard fork happened, both Geth and Parity have significantly optimized their implementation of these precompilers so that they are significantly faster. And so there's an IP to update the gas schedule to reflect this increased efficiency. It didn't make it into the continental middle hard fork, though, which was for us. It was a bit disappointing. But we understand there are the Ethereum community as a whole has a lot of other high priority considerations in private transactions, and this kind of these precompilers doesn't really rate very highly just because no one's really been using them much. But we do have an interim solution. Sort of. It's something we've been working on for quite a while, which is effectively the purpose of the precompile is because the rationale is that if you wrote the algorithm that this precompile does, scalar multiplication, if you wrote it as a smart contract, the gas cost would be way too high, and therefore you add a precompile in to make it cheaper. However, we have, as of yesterday, publicized a repository we've been working on called Via Strudel. It is an implementation of a short Weierstrass curve, the same curve that the precompiles reference, and it does scalar multiplication, and it is faster. Well, I'm not sure about faster, but it's more efficient in terms of gas than the precompiled smart contract. So by about a factor of 30% for our use case. So we're very excited about that because that's going to bring the cost of an AZTEC transaction down, hopefully by up to 200,000 gas, from around 900,000 to 700,000, which will be a very welcome addition. So yeah, it's on our AZTEC repository. We go AZTEC/ViaStrudel. Probably best just to look at the root level of our organization and then click on it. But yeah, so that's all there.
Okay, thanks. I will keep quiet for a while. I'm sorry. Rest of the team, do you have any questions?
I wanted to ask you a small question. Does the AZTEC protocol work entirely on-chain, basically, or does it need some sort of nodes working in parallel in some other network to support it to work properly?
Sorry, I didn't quite catch the first part of that, but I think I got the gist. You're asking if you extra kind of like another layer, like a layer 2 solution to support it. You don't. AZTEC at the moment is fully a layer 1 solution where our validator smart contracts is kind of the ultimate arbiter of whether a transaction is legitimate. It doesn't need any kind of off-chain help or off-chain nodes.
But you do need an NPM module to create the AZTEC nodes in the first place.
Yes.
But you can have multiple implementations for that. We currently developed one in JavaScript, but if you need some TypeScript implementation, you can just do it yourself. It's not like something fixed in place or like some sort of server. It's just like JavaScript implementations.
Yeah, absolutely.
Okay, I think Pala is having some problems with the sound, so he sent a question, and I will read it. Would it be possible to implement a confidential ERC 721 with AZTEC?
I'm right thinking ERC. Sorry, memory is like Swiss cheese these days. ERC1 is the non-fungible token standard.
Yes.
So that would be a little bit tricky because what AZTEC does is it encrypts, it hides the value of a transaction. It doesn't hide who owns, like if I, for example, say these AZTEC for like upstairs, it doesn't hide who owns these nodes, and it doesn't hide what the asset that node corresponds to. So I believe because in ERC 721 it's non-fungible. There's only one of them that you can't really. There's not a lot to encrypt there. I might be completely wrong about that though.
Well, I think you can encrypt like the metadata, like the URL to the metadata. But depending on your application, that might not be that helpful. It's like in the case of ERC20, you have like an actual balance, which is like a number. So you encrypt that, and that's where your benefit comes from. In the case of ERC721, you have like metadata for every single item, like its picture, whatever, and you can encrypt that. It can be helpful. It can not be helpful. I think it depends on the application.
Yeah. Also, as a kind of, it's not really something we've been really experimenting with much, but if you have something like a CryptoKitty system where you have your digital assets, your 71 tokens have like traits that you can combine with other tokens to create like different different kinds of non-fungible tokens, then you can encrypt those using the AZTEC protocol. And so basically you can hide what traits your asset has, and but still use them to create to interact in the way that you would traditionally expect. But that is not something we've done a huge amount of exploring on.
Thanks. And let's see, a follow-up. You have shielded and unshielded transactions in the same ERC20 with AZTEC as in Zcash, or is it all or nothing?
So it's AZTEC is very flexible. You can bolt it on to an ERC20 token and get both shielded and unshielded transactions, or you can use the confidential token kind of as a standalone asset and have no unshielded kind of transaction at all, if you want to, which is something we're quite excited about, because for example, something we're experimenting with is if you take, for example, take a syndicated loan or some kind of debt instrument, you can construct your initial register of owners of that instrument in using an AZTEC node registry and never have a public form, never have any kind of unshielded representation of that loan or that asset, and that gives you an enormous increase in the amount of privacy that you enjoy. Because if you have a public and if you have an ERC20 token with its AZTEC counterpart, then obviously every time you convert ERC20 tokens to or from AZTEC form, you reveal a little bit of information, because obviously people can see public tokens going in, disappearing into the AZTEC ecosystem, so they will know that your AZTEC balance will be at least the amount of tokens you've added, and similarly when you take them out. But if you have a completely private system, that all goes away.
Essentially, the more users one contract has, like an AZTEC contract has, the more privacy there is, because you cannot track like who owns what inside the contract. Well, if you want to withdraw to the normal ERC20 world, you have transfer events, so you can know like how much was transferred. But if you are using like an extra, like a completely different token built from scratch as a confidential AZTEC token, there is no back and forth between the public ERC20 world. It's just like privacy from day one. So it depends on which route you're going to, but it is definitely possible to have only shielded transactions.
Thank you. Any other questions? Anybody else? Okay. Do you want to share something else with us, Paul, Zach?
No, I think we kind of, on my end, I covered everything I wanted to talk about. Just other than stay tuned for, we are kind of imminently close to, so as we're planning today on releasing this cryptography engine token standard, and follow that up with our confidential token standard, which we are super excited about. It's going to be the kind of the missing link of what we've been trying to build. And like give developers the ability to create meaningful private assets, which we're super stoked about.
I think I had one question regarding Zeppelin. Of course, like having something like AZTEC deployed on the Zeppelin OS network would be, I guess, very helpful for developers, because they would not have to pay the gas to upload the contracts in the first place. So I'm curious, I know that you're in beta now, correct me if I'm wrong, but like, is there any estimated time of release for your operating system?
Sure. Let me get that one. Can you hear me okay?
It gets a little noisy when you move, but if you stay still, just move your lips, that will work.
Okay, I'll be very, very quiet and try to be as un-Italian as possible. Okay. So I'm half Italian, I can say that. Okay, so the idea is we do have a private beta going on, but the private beta is just for the token. The token within the system is going to be used to vouch for the security of EVM packages that are deployed on the network. But today you can deploy as many EVM packages as you want, and users can freely use them. So regarding usage and having presence in the network and share your code with other Zeppelin OS users, that's completely open. You can start doing that today. And they'll be very happy if we set up a shared channel and start discussing a bit more about that. If you're also interested in jumping on the private beta and start discussing about options for having your users actually vouching for the security of the contract you're uploading, then that's a separate conversation, and we can also see if you want to join the private beta and start playing with those cryptoeconomics as well.
Sounds awesome.
Yeah, it really does. Thanks.
Yes, super exciting, your release. Good luck with that. Thanks a lot for your time. It was really interesting, and well, I think we will be bothering you more as we learn about your cryptographic proofs. And for people watching, your website is aztecprotocol.com, right? Right. There's a lot of information there. I was looking for the white paper that I read a while ago, and your link is missing, so I sent an issue report in there. I'm now even more curious to read the white paper.
Sorry, it got broken when we merged on monorepo. Paul's just going to link it to you in chat.
All right, so have fun, have a nice day, and good luck with your project. We'll be talking later.
Yes, it's been great.
Hi, everybody.
Thanks, guys.
Have a good one. Bye-bye.
Thanks, bye.